Let's assume the Earth has two moons. Have you ever wondered what Earth would be like? How would the night sky appear? Would our tides change due to the combined effects of the gravitational forces exerted by the two moons and the Sun and the rotation of the Earth? Would they collide and explode? The Moon, the most beautiful sight in the night sky. The Earth's satellite does not just rotate around it, also has obvious physical effects on the planet. For instance, the attraction between the Moon and the Earth is responsible for the creation of tidal waves in our oceans. Then there's the matter of moonlight. The light that we see at night is, in fact, a reflection of the sun's rays on the moon's surface. So, of course, the moon has no light of its own, as it's just one huge round rock. Our moon is 1/81th of the size of the mass of the Earth. This is a unique relationship, as most moons are about 3/10,000th the size of their planets. This relatively large size of the moon is responsible for its huge influence on life on Earth. As we've already mentioned, the moon is responsible for tidal waves, but it also contributes to the length of our day, as we will explain later. The moon also plays a role in the cycle of seasons that we experience each year, as it keeps the planet tilted at a constant angle. But just before we dive in too deep, let's take a brief history lesson about the moon. The origin of the Earth's moon dates back to some 4.51 billion years ago, when a Mars-sized body called Theia crashed into the Earth. The impact of this devastating collision caused debris to be blasted into the Earth's orbit, and over a period of time, this debris came together to form what we now know as the Moon. Ever since, the Moon and the Earth have been involved in a cosmic dance, as each body continues to influence the physical phenomena taking place within them. But have you ever thought to yourself, what if Earth had more than one moon? What if there were two moons? Some scientists suggest that when the Mars-sized protoplanet crashed into the Earth, there was a formation of two moons. It's been assumed that these two moons came together to form the moon that we see today. So while it's a near impossibility for Earth to have another moon, it's interesting to consider what the implications of another moon orbiting the Earth would be, and how this extra moon will affect life on Earth. The effects that a second moon will have on Earth will be determined by the size and the distance of the second moon from Earth. So let us imagine that the second moon is about the same size as our regular moon, and that it orbits the Earth at just half the distance between a regular moon and Earth. Well, the first visible effect of this will be seen in our sky. Rather than seeing just one moon in the night sky or the early morning sky, we'll now see two moons. And despite the fact that these two moons are of the same size, the new moon, which is closer to the Earth, will be almost twice the size of our regular moon when we look at it from the ground below. In truth, this will be such a beautiful sight to behold, and at night we'll have a brighter night sky as the rays of the light reaching the surface of the two moons from the Sun will be reflected to Earth. A brighter night sky will also affect wildlife. It might increase the number of nocturnal animals, because nocturnal beings will be able to see their prey more easily. However, because of the extra light, prey will also be able to see and spot danger more easily at night. This will force nocturnal predators to evolve into better hunters. With two moons up in our sky, we'll also have to come up with a new way of marking our months. This will affect early religions and other organizations that take their inspiration from the phases of the moon. Then we have to consider the effect of two moons on any navigation that's based on the movement of the moon, and this will mostly affect marine life. Also, animals whose mating habits have been tied to the visibility of the moon will have to come up with different evolutionary pathways that will define their mating periods. And for scientists, the presence of an additional moon will present more opportunities to observe solar and lunar eclipses as they'll become more frequent. Well, all these changes we've mentioned would be easy to adapt to, but perhaps one of the more difficult changes that will occur on the surface of the Earth due to the presence of an extra moon will be the change in tidal patterns. Tidal waves on the Earth's oceans are likely affected by the movement of the moon. To understand how this happens, we must consider a vital relationship that exists between two bodies in space. Any two bodies in space are bound by a force of attraction, and the magnitude of this force is inversely proportional to the distance between these two bodies. With the distance of the moon from the Earth being between 356,000 to 400,000 kilometers, the gravitational force of attraction between the moon and the Earth is quite significant. Consequently, the moon pulls out the body of water closest to it, resulting in an increase in the height of tidal waves in that region. The moon also pulls on the Earth's crust itself, and because the force of attraction between the moon and the Earth's crust is stronger than the force that exists between the moon and the water bodies on Earth, the body of water in the opposite side of the Earth, that is, the side that is farthest from the moon, will also experience high tides. Now, considering that this is how one moon affects the tidal waves on Earth, imagine what will happen if we have two moons. Well, once again, we must remember that the effects that a second moon will have on the activities of the Earth will be dependent on its size and location. If the second moon is located at the same distance from Earth as our regular moon, then the size of the tidal waves will be bigger, but they may not be devastatingly bigger. However, this will not be the case if the second moon is closer to the Earth's surface than our regular moon. If the distance of the second moon from the Earth's surface is half the distance of our regular moon from the Earth, this could produce tidal waves that are 6 times taller than the tidal waves we have now, and that will be devastating. Tidal waves could reach as high as 300 meters. This will make living in coastal areas almost impossible, and cities like New York, Singapore, and London will become the lost cities of Atlantis. Marine animals will be forced to evolve differently so that they can adapt to the changes in the tidal waves and be able to survive in both high and low tides. The huge tidal waves will also affect how we travel. We'll have to ditch traveling on water altogether or design new technologies to cope with the high tidal waves. Eventually, the Earth will adjust to the new sea levels, and one can expect that with time we'll settle down and get used to the new environment. But hold on a minute, that might just be wishful thinking. Beyond the massive changes to the tidal waves, another phenomenon occurs in the relationship between the positions of the two moons. Again, let's imagine that the two moons are both of the same size and at the same distance from the Earth. While in orbit, the two moons will most likely remain in place for millions of years. But eventually, one of the moons will slowly begin to move farther away from the Earth. As this happens, it'll disturb the orbit of the other moon. Inevitably, these two satellites will end up in a slow-motion collision. As the two moons slowly collide into each other, the debris of the smaller moon will be spread around the first moon, covering it with an extra layer of solid crust. With time, the first moon would be left standing alone, having swallowed the second moon. While all these go on, the Earth would remain mostly undisturbed. However, in another scenario, this will not be the case. Let's go back to a situation where the second moon is just halfway between the first moon and the Earth. While in this position, the second moon will be subjected to gravitational forces both from the first moon and from the Earth. It'll find itself in a cosmic tug-of-war. Only that in this tug-of-war, it stands no chance of winning. Due to the combined pull on the second moon from the planet and from the first moon, the second moon will be subjected to huge tensional forces in its crust. This will trigger a host of enormous volcanic eruptions. The second moon will then just be covered in red-hot lava, morphing into an appearance similar to the one that's seen on Jupiter's moon, Io. But while the Earth, together with the first moon, rips apart the second moon itself continues to pull on the Earth as well. In fact, both moons continue to pull on the Earth. This happens as the moons continue to move farther away from the Earth. Currently, our moon moves an estimated 3.8 centimeters away from the Earth every year. This is equal to the growth rate of your fingernails. But as the moon continues to pull on the Earth, it slows down the rotation of the planet, increasing our day by at least 1 second in every 40,000 years. Now that may not sound like much, but with two moons in place, this process becomes even faster, so that in 1 million years from now, our day will have increased by 16%. We'll now have a day that will be 28 hours long. But while the two moons work together to slow down the rotation of the Earth and increase the length of each day, they periodically get closer to each other. The second moon will keep drifting closer to the first moon, and after millions of years, the two moons will collide. This time around, the collision will rip the moons apart from the core. From Earth, we'll observe a red light in the sky. It'll be an ominous sign of an apocalypse. Following the violent collision between the two moons, the Earth will become the dumping ground of a meteor shower, as thousands of massive rocks will be hurled towards the Earth's surface, leaving huge craters and wiping out life on Earth as we know it. Every moving animal and every living plant will be consumed in an inferno. But as one world ends, another will begin. Following the collision, the remnants of the crust of the two moons that did not make their way to the Earth's surface will form a ring of debris around the equator of the Earth, as they'll be trapped by Earth's gravity. It'll be a sight that's similar to the planet Saturn and its famous ring. But this ring of debris around the Earth will not be permanent. Within a few years, these rocks of debris will clump together and form yet another moon. By that time, new life forms will have found their way onto what was formerly known as Earth. It's only speculation, but it's difficult to tell whether or not these life forms will be a species intelligent enough to give its new habitat its own name, or whether they'll be aware enough to tell the history of the planet they will have found themselves. Or maybe we're just getting ahead of ourselves. After all, we've only built these theories on a mere assumption, an assumption that we have two moons. So, did you enjoy this video? What did you think of Earth with two moons? We'd like you to share your thoughts in the comment section below. Don't forget to like and subscribe. See you in our next video.